Hello, this is Mrs. Scarpel, and in this video I'm going to go over interpreting function notation with you. We are going to write a function first, and then we're going to identify what the different parts of the function mean and go from there. So in this example, we have Allie and Dane both work at a water park, and they are required to drain the water at the end of each month for the ride they supervise. Each uses a pump to remove the water from the small pool at the bottom of their ride. The graph given represents the amount of water in Allie's pool, A of x, that's the red line, and Dane's pool, D of x, that's the blue line, over time. Dane figured out that the pump he uses drains water at a rate of 1,000 gallons per minute and takes 24 minutes to drain. Write the equation to represent the draining of Dane's pool, D of x, and then what does each part of the equation mean? Well, we know the rate for his function. It's given to us as 1,000 gallons per minute. We're also told how long it takes to drain the pool, so we can calculate how many gallons of water there are to begin with. To find the amount of gallons that we start with, we take 24 for the 24 minutes times the 1,000 for 1,000 gallons each minute to find that Dane has a total of 24,000 gallons of water in his pool. I'm going to go ahead and label that on my graph. Oops, I almost wrote the wrong number. And we know that he finishes at 24 minutes. So we have the rate, which is the slope, and we have the initial amount, which is the y-intercept. So we can write this function in slope-intercept form, or if you would rather, it can be a variation of slope-intercept form. Instead of mx plus b, we could do b plus mx. So we know that he is starting with 24 gallons. Because he is draining, that's a minus 1,000 gallons x. So let's identify the parts here. 24,000 is the initial amount. The minus 1,000 is the rate in gallons per minute. X is the number of minutes. And the expression, the notation D of x, is the amount remaining in the pool. So every single piece of this function has some sort of meaning and context. Number 2 says, based on this new information, correctly label the graph shown. We have done that already. However, we can add a scale to our minutes. So if I look at how many markings there are till I get to 24 minutes, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divide the 24 by 12, and that tells me that every mark is 2 minutes. So we can label this 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And we have labeled our graph as well as we can. If we look at our next statement or question, what values of x make sense in this situation? Write the domain of the function that represents the amount of water in Dane's pool. So if we go back and look at our graph, domain is the set of inputs we can use, so the set of x values. It makes sense to use x values from 0 until 24 because that's when the pool is full until the pool is empty. So the domain, using interval notation, is 0 to 24. What output values make sense in this situation? Write the range of the function. So the range, as it was mentioned, is the set of outputs. At 24 minutes, we have 0 gallons in it, and at its largest value, 24,000 gallons in it. So our range is from 0 to 24. Or not 24, but 24,000. Now we're going to take a look at Allie's equation. Here we have a graph that has grid lines on it, has a scale on both the x-axis and the y-axis, which is going to help us with Allie's equation. So we know that Dane's was at 24,000. And if we look at the y-axis, there's 1, 2, 3, 4. Every 5 is another 10,000. So that means every 1 is 2,000. That tells me that by looking at this graph, I can see that Allie starts at 28,000 gallons. To help me find my slope for Allie, I'm going to go to this point where the two functions intersect, which is at 14,000. So we go down 14,000, and we're going to the right 10 minutes. So the slope is going to be negative 14,000 divided by 10, which is, forgot a 0 on my 14,000, negative 1,400, or 1,400 gallons per minute. So for Allie's equation, we're using a of x. Her initial value is 28,000, and hers is decreasing at a rate of 1,400 gallons per minute x. The domain for Allie is different from Dane's because Allie is done in 20 minutes. Her pool is empty in 20 minutes rather than 24 minutes. So her domain is from 0 to 20, and her range is also different because she starts with more water than Dane. So 0 to 28,000 is her range. So what does it mean when a of x equals d of x? I pointed on the previous slide that they were the same at 10 minutes. They have the same amount of water in their pools. So this means, well, first, when is a of x equal to d of x? At 10 minutes. What does it mean? They both have $14,000 gallons left in their pool. Find A of 5. Well, the thing you need to remember about the 5 is that it is an input. So I could do this two ways. I could look at the graph, find 5, and go up, and it appears to be 21,000. Or I can take Allie's equation and substitute the x with 5. So we have 28,000 minus 1,400 times 5. That's 28,000 minus 7,000 for a total of 21,000 gallons. So what does this mean? At 5 minutes, Allie has 21,000 gallons in her pool. If d of x equals 2,000, in this case, 2,000 is an output, so we want to look at the vertical axis at 2,000, then x equals, and we're looking for Dane, so we're looking at the blue line. So 22, if I look at the graph, here's my output of 2,000, occurs at time 22. Now I could also find it algebraically. I could set 22 or 2,000 equal to 24,000 minus 1,000x. I can subtract 24,000 from both sides. That gives me negative 22,000 equals negative 1,000 x divide by negative 1,000. And we find that x equals 22. So what does this mean? Dane has 2,000 gallons in his pool after 22 minutes. When is A of x greater than D of x? Remember, A of x is the red line. D of x is the blue line. So when is A of x greater than D of x? Well, it appears from the beginning, Allie's pool has more until they get to 10 minutes. So I can write an interval for this. I can write that it's from 0 to 10, but I'm going to use a parenthesis on the 10 because that's the point where they're equal. So what does this mean? For the first 10 minutes, Allie has more water than Dane. So this is our conclusion of using function notation to write an equation that represents a graph, but also to interpret meanings within the context of a situation.